Okay, to continue on with literals. So right here we have apples equals 20. Now apples is a variable, 20 is a numeric literal, so it is a literal. You cannot change 20 to anything else. It's a numeric numeral which cannot be changed, so it's literal. Today we sold is a textual literal. So now the next thing I want to introduce here are these plus signs. Think of the plus signs. Most time we see a plus sign we think of as addition. In this case it's a concatenation. It's glue. It glues this piece to that piece. Another plus sign glues that to that. So it's called concatenation. It allows us to take several pieces and join them together. So in this case, we've created a variable called apples. It's an integer data type. We've assigned it the number 20, a literal 20, and then we're going to go ahead and say print that line out. Today we sold basically this apple, the numeric value it's inside of apples, bushel of apples. So when I run this, it comes up and says today we sold 20 bushels of apples. So string literal or a numeric literal. Today we sold is a literal. We can't change that. It's text. So literals. Now, when we talk about variable names, we have some different rules. Again, we always want to make sure our variables start with a lowercase. That way there, if it does happen to go to uppercase, for some reason we know we've used some type of a keyword. It cannot start with a numeric digit. It cannot start with a space. We cannot put special characters in our name like pound signs and periods and those types of things. We cannot use spaces. So when we're naming things, we always like to use something called camel casting. If you look over here on the screen, a comment is just a slash slash. So in this case I can type bushel uppercase apples. So again, we always start our variables off with a lowercase, but if I'm going to put two words together, or maybe even three or four, always make sure we put an uppercase letter on the next word. It's camel casting, so it goes lowercase, uppercase, lowercase, lowercase, uppercase. That's how we get camel casting. Again, good variable names. Now, let's continue on with the different variable types. Now we talked about byte, short, int, long, double, and float. Those are what are called primitive data types. Now, a primitive data type is a data type that it literally holds the data. It literally holds the numeric value. We'll get into relative variables in another chapter, but just know primitives actually hold the data. The data resides right there inside of that variable. It doesn't reside anywhere else. So that's basically what a primitive means. Most of our primitives we're going to be using are numeric primitives. They hold numeric data, and we will get into some more unique primitives in some other chapters, but for right now we're going to use byte, short, int, long, float, and double. And realize each one of those, again, on the bottom of, or in the middle of page 45, it shows the numeric values of each one of those. Now, if we bring in 2-20, which happens to be the integer variable, I drop it on top of the package, I click copy, and again I have to go in and click on the light bulb X, and that will get me to add the declaration, save it. So if we take a look at this, here I have an int called checking, the variable name is checking, a byte miles, so I got a variable miles, it's a byte data type, short is minutes, long and days. Now remember, a byte data type only goes up to a positive 127 or a negative 128. So checking I've set to 20. Checking is an integer. Miles is equal to 105. Miles is a byte, so we're legal there. Minute is 120, and days is 185,000. And days is a long, so we basically have the correct one. Now I could not assign 185,000 to, let's say, a byte data type, or even a short or an int. Now we could do it to an int, not a short. So here we've basically set our print line. We have journey of that many miles. It took us that many minutes. Again, we're using the print line, so it's forcing a new print on the bottom of each line there. Okay, so let's continue on to, let's talk about the numeric values. So we've used an int so far, and an int is what's called a primitive data type, and a primitive data type is just that. It holds the data itself. In the future we'll get into some relative variables, and again we'll get more detail on those later, but primitives actually hold the data. It's stored right inside of that. So byte, short, int, long, float, double. I think we've covered those in the previous video. So let's talk about the numerics. So we'll get into integer variables. So here we have int, byte, short, long, days. So here's an integer, here's a byte, here's a short, here's a long, and we've assigned numeric data to each one. Now an int, remember we talked about, if you look on page 45, it shows the different values that it'll hold. A byte, short, long. So checking is equal to a negative 20. Checking is an int. That surely is big enough. A byte is set to 105. That's within the range, because a positive 127 is as big as you can go. Short is set to 120. Days is a long. It's set to 185. So basically works fine. If I were to run this, it comes up and says we've made a journey of 105 miles. It kind of goes through each one of those print lines right there, so we can kind of see how they work. So if we open up the sun facts and bring those in, now we're dealing with scientific notations. The scientific notations is kind of weird. It's got this E in there, and that basically, think of that as representing the number 10, and so that's 10 to the 11th power multiplied times 1.495979 is basically what that means. And then the E30 is again 10 to the 30th power multiplied by that number. And it talks about the sun is that distance in meters away, and the sun's mass is that in kilograms. So if we were to run that, we can basically see that printed out in those. And again, now if you notice, I have double distance comma mass. What is that doing? Well, what that is doing is that's the same thing as this. So I can do it in two lines. Now the one thing I can't stress enough is the semicolon. The semicolon is the that basically ends a statement in Java. So we have to make sure we have a semicolon at the end of every statement. Notice I have sun is. Now another thing I've done is I've got these plus signs. A plus sign is basically a glue. Think of it as glue. It glues two things together. It's called a concatenation. So I can concatenate two items together. In this case, I have the sun is, and then I've got distance. I've got distance, and it's got a plus sign, and so it says the sun is that distance, and then we glue meters away at the end of it. Okay, so if we look right there, it says the sun is, and it's got that statement meters away. So it's got one big long statement glued together with our concatenation. So there's a literal, there's a variable, and another literal. Another way to look at this, if I were to look at sale's doing the same thing. It's got well, it has a double on here. Let me put a double back in there. Same thing. Instead of having three separate lines, I can, if all my variables are going to be the same data type, I can go ahead and say double variable name, comma variable name, comma variable name. So I've just declared three variables, all the same double type. And I'll go ahead and set that variable to a numeric literal, that one to a numeric literal, and that one to a numeric literal. And then I could do the same thing. So if I were to run this, the price of the item is that, that, and that. Now if I make it a float, watch what happens. A float is a decimal type as well, but we get red squiggly lines. Whenever we see red squiggly lines, that says something's wrong here. Now again, I can click on the little light bulb and it's going to give me some suggestions. Add cast. Well, we haven't talked about cast yet, and it says change the price to double. Now this is why double is used most of the time. In fact, double is the default. To use float, I have to let the string or the numeric literal know I am using a float data type. I have to actually put a lowercase f behind it. And now the numeric literal is saying I am literally a float data type. If I don't have anything, I default to a decimal data type. And will this work? This should work just fine. So when I run it, I get the same exact thing. Okay. So just a couple of different ways to make sure that we use the same, we can use the same declaration, one line, to declare multiple variables, and that works just fine.